The idea was to float this cube in the air. And this is an opportunity to really show what we can do. Now we know on the computer where all the forces are. And then we had these very light beams going between them. But then I had a funny meeting with the client. When you haven't built something, you can't really say 100% that it's going to be possible. We had a fantastic inquiry from an agency in Soho again. All the agencies were in Soho. You could almost drive to Soho and meet an ad agency, win a job and come home. But the agency in Soho came up to us and they had a project for Smirnoff. And what I'd wanted to do with Steve and the engineers is I wanted to kind of have some synergy between the engineering and the inflatable. So if you make a really big inflatable, you might need some trussing. Certain size inflatables for outside, you don't need any trussing or substructure. But if it gets really windy, they can move a bit like a blancmange. And that's natural. It doesn't necessarily mean they're going to flow away, but you get some deflection. Now, some clients will be very kind of allergic to that deflection. And so you will engineer it to minimize that deflection in operational wind levels. I'm getting a bit technical now, but I got to touch on it. So this project with Smirnoff, we were floating. The idea was to float this cube in the air. Now, you can't really float a great big cube in the air. And it had this kind of bar that goes around the outside. And so it's like kind of this cantilevered looking cube, which looked like a nightmare on one level. But, you know, we'd built a good relationship with Webb Yates by then, and we'd done a few structures. We'd done some integrated engineering. And I was like, this is amazing. This is an opportunity to really show what we can do. And I was like, this is fantastic. So I was like, right, we can make the inflatable elements. We know what to do with that. That's straightforward. What we need to do now is design this amazing truss system that will support the cube and hide within the structure. But where it's not hidden, I was like, well, can't we really kind of reinvent what the trussing is? And you know, we started a bit of a conversation around it. And it was like, normally a trussing is like a series of triangles. And I was like, no, but we know full well the forces. Now we know on the computer where all the forces are, and we were laser cutting stuff at the time. I was like, can't we design the trussing and follow where the forces go? So basically we only engineer and build a truss for where the forces are, and everything else we leave away. So we design these special corner junctions where all the forces really are pressured on. These corners where all the bits come together. So with these fantastic kind of designs that look like lattices, but they were form follows function. They were just the shape of forces. And then we had these very light beams going between them, which were enough to hold lighting and AV and everything else. So we were kind of sculpting the engineering. I wanted the engineering to be honest, so that people could see the truss was a visual of the forces. Anyway, I was very excited, and as always, I got heavily carried away with that. But then I had a funny meeting with the client, because when you haven't built something, you can't really say 100% that it's going to be possible. You know, you can say it's 99.999 and sling lots of nines on the end and get everyone excited. But still, you have to leave the 0.0000001 for an eventuality. And I ended up in what has become a common feature of my life since then, which is the owner of the agency panicked, like, oh my God, you're doing this trussing and it's the exposed engineering and we got this and it's costing this and it's going to be this and we've got this cube on a frame and it's got to go up. Can it go up? Can it do this? Can it do that? And I was listening, thinking to myself, well, yeah, it can do it, but I didn't want to oversell myself. I wanted to be honest about where we're at. I said, look, we're pushing the boundaries here. We're doing things that haven't been done. You came to me for an amazing structure. Here is an amazing structure. It has, you know, we thought about everything. We've got the form of the cube and what we want to do and how that's going to look and how the bar and the DJ works. And we've engineered it to really perform in all types of weather conditions. We have a concept of how we're going to erect it. We've never done this before. We've never set a structure up like this. We're building in the air in a festival. It's going to be things we need to learn. We'll have to go live and we'll see what happens. You know, it'll be a challenge. We'll put the team on it. And they were like, no, we're really panicking. I'm really not sure. I need you to tell me 100% that it's going to happen. And I was like, let's make it simple. This is the price of what it all is. And I'm so confident that if it doesn't work, I won't charge you. But I said, it's not fair that I take all the risks. So if it does work, you pay me double. I said, that's fair. So what do you want to do? I take the risk. If it doesn't work, you don't have to pay. And if it does work, I want double. And they committed and we went ahead. And it did work and it was fantastic. And it worked exactly as planned, but I needed to tip them. But I didn't want to say it could definitely happen because we couldn't say that with all honesty because there is always a risk. And that was a really big step shift. We really built the relationship with Webb Yates, we built the relationship with the agency, and it went on tour and became a really cool structure. And we took a lot of learning from that into other projects. And some of these other projects then bring us new learnings, which I'll go on to, which kind of pinpoint some of the steps that we made with the bigger outdoor structures, which allowed us to formulate more of where we are now.